Hail to the king, baby. Hadouken!
Winner, winner, sheen dinner.
Prove me wrong, that'd be great.
Hello, welcome back to A Boring Revolution, your number one news source for everything in regards to the Boring Company. As you were in my previous video, I outlined a proposal or outlined the problem and then talked about a possible proposal that I would do in regards to water shortages in Mexico at the Giga factory that's set to be built there. I have produced a costing of that and the rationale behind the decisions that I've made, plus some plans, and hopefully you guys are going to get excited about this, because this fixes a lot of problems. Not only does it fix all the water shortage problems for Tesla, but I'm hopeful as well that with all the additional suppliers that are going to come into this region, potentially in the area in and around the Gigafactory, they will also fix their water supply issues and possibly some residential water supply issues as well, although not the entire region. But it certainly is a big help and can be replicated in other areas. So, as you know, construction is set to start at the Tesla Gigafactory site in Mexico in the next 2 months. I have a fully costed water solution. So, as you can see, this is our site. Looks very lush and green. That's a total fabrication. In fact, it's extremely dry, extremely arid, and this actually at some point was a river. Probably not a very big one, but anyway, it is bone dry. So, the solution is not just to leave things the way they are, because rainfall is continuing to fall below expectations in this region. So what you need to do is you need to look around, find where there are abundant supplies of water, and bring those abundant supplies of water to where they are needed. It is just a case of finding the right engineering solution, and that's what I'm going to show you today. So as you can see, this is our site here. Extremely high elevation there at the back of the site. Yet despite this, there is very low rainfall in this region, and most of the rivers are heading either in from a different region or out of the region, basically bone dry. There's nothing in the rivers, so it's a problem. The Boring Company can provide the most cost-effective solution to this problem. I have no doubt about that. This is the best solution. There are no other better solutions. There was an aqueduct proposed in this region for bringing water down to Monterrey, which is the big city, and apparently that has been delayed and potentially even cancelled now. So this is the best solution. It costs less and it can potentially move more water, and if necessary you can expand it to move much more water. So just to remind you, this is the site that has been purchased by Tesla for the Gigafactory, right next to the city of Monterrey. As you can see, it is a huge site. I'd say around 25% of that area is unusable though, due to the elevation differences, but overall it's pretty good. I have drawn a nice big blue line on this map. And the reason I've drawn this big blue line is that in this region there are lots and lots of existing water infrastructure. I'm assuming that there are some that run along this road that goes through Santa Catarina. In fact, I'm 99% confident, but I don't know the exact locations, but that's not a problem. We can leave that to the local authorities to rectify, and we're not going to cost that today because it's in their interest to do that, and if so, Tesla can chip in a little bit of money to do that. But what we're talking about today is actually increasing the supply of water within the region. Now, the obvious place to get this water is the Rio Grande. Now, I am into... there's no illusion in my mind that there are some issues with the Rio Grande occasionally, but throughout the year, vast majority of the time, there is more than adequate water in this river. Certainly parts of it do dry up from time to time in peak summer season, but during the wet season there are millions of cubic feet of water passing through this river. if you look at this river, at where it terminates into the sea, it is 125 metres wide and it is close to 5 metres deep. There is more than enough water to go around. In my mind, the fact that it's 125 metres wide, when it actually exits into the sea, it illustrates massive wastage. Because you're not using that water. That is fresh water. As soon as it goes into the sea, it is almost useless because it's contaminated with seawater. So what we want to do is reduce that flow down and utilise water at certain periods of the year. Now, certainly when there's dry periods, I'm not going to recommend taking water out of a low river. But there's going to be certain periods where the river is well above a metre deep. And I'm going to suggest that during those periods, water is extracted in very high quantities. So think of it a bit like a battery. You know that you're going to need that electricity, that water. You take it, you charge it when you need it. And at some periods you can't obviously charge it, so you've just got to use what you've got. That's the approach. So I'm well aware, so certainly people in the comments are going to be saying, hey, there's water shortages and don't take it from there because you can't use it. You can. There's plenty of water in the Rio Grande. Millions and millions and millions of cubic feet of water. So we're going to take some. And it's definitely legal. It can definitely be done with the right willpower. Pumping groundwater is not a viable long-term solution because in 15 to 20 years' time, you'll end up with a load of boreholes that are 200 feet deep and they're empty. So it's not a viable long-term solution in my opinion. Now, this reservoir here is going to be our saviour because it's going to save us an absolute monster ton of money because we're going to just use it. Because at the moment, it's below 50% capacity. So why not put some more water in it and then use the existing infrastructure that's already tapped into this reservoir, including water treatment works, and just pipe that into the Tesla Gigafactory. Obviously, that might result in the need for some new mains pipelines. The local authorities can deal with that. I'm going to suggest putting in one that's about 500 mil or just under 2 foot in diameter. I think that would be kind of perfect, and just run that into the city or around the city. It looks to be some kind of ring main that goes around the city, so you could just connect into that and then connect that up to the Gigafactory. It's not too difficult. These sort of things happen every day in cities all over the world, so it's no rocket science. So there's a potential connection there. We know there's water supply in a place called China, which is kind of ironic that it's called China, but it's right next to this reservoir, so we're just going to utilise that. If you remember from my previous video, we made some assumptions. I am not sure they are correct because I don't have enough detail about what's being built in Giga Mexico. I don't believe there's any finalised plans, so I can't really make any decisions without making assumptions, but I'm going to be cautious, and I'm going to assume that Giga Mexico will consume 2.1 million cubic meters of water per year. So if we wanted to protect ourselves, or Tesla wanted to protect themselves against water shortages, I would recommend that they keep at least a 10-day supply in addition to what's available in the local reservoir system. It just makes a lot of sense. Why not just keep that water, just in case there might be some kind of issue, maybe there's a breakage in the pipe, maybe the water runs out in the reservoir, but you've got that water there ready to use and you can ration it. So a 10-day supply is 57,540 cubic meters, and the reservoir required, which will be an underground reservoir because we want it to integrate into the existing site, is 80 meters by 60 meters by 12.6 meters deep. It's not too bad, 12.6 meters, you can blast that away. Or you can use excavators, but I presume that drill and blasting is the best way forward. Okay, so here is phase A of our Gigafactory. Yes, I'm well aware that there's going to be 2 phases, so there's going to be 2 of these. Here's our reservoir, just to give it kind of scale. 80 meters by 60 meters by 12.6. That'll all be underground. It'll be poured in situ concrete frame. proposing that the columns will be at let's say 10 meter centers, and the spans between the columns will be 15 meters. Use steel beams or steel frame above that, potentially with a transfer deck, although probably you won't need that. So then you use concrete planks on top of that. They'd be prefabricated. You could throw this up very easily in well under 8 months if you really put enough men on the job. Easy peasy. There's nothing too difficult about that. It'd all be underground, protected from the elements, so you don't need to worry about evaporation, because existing reservoirs in this area obviously suffer massive evaporation issues, and it's better sometimes to have it underground. Okay, so this is a godsend that this is so close. So it's the Presa Cuchillo reservoir, which is already connected up to a river, but this river apparently is not filling it fast enough. So here's a little statement. The El Cuchillo Dam is located in the bed of the San Juan River. It was inaugurated on the 17th of October 1994, so not that long ago, by President Carlos Salinas de Gortari. It has an area of 18,000 hectares and the capacity to store 1.12 million cubic meters of water. The dam is amongst the 10 largest reservoirs in northern Mexico. In February of last year, it had a stored volume of 603,000 meters cubed, which is 54% capacity, which is not good, but I'm presuming that it goes up to close to 80-90% capacity during the wet season, which is sort of between September and April, and due to a lack of rainfall it fell to 46%. So there's plenty of capacity there for shipping in our water. Here's our red line, which indicates the tunnel. The tunnel is going to be fairly deep at this point, possibly as deep as 40 meters, maybe slightly more. So ultimately you're then going to have to pump the water up and into the reservoir or into the water treatment works for then shipping out to Giga, Mexico, or Giga Monterrey, however you want to call it. So here it is on the map. This is our route. Yes, it's a perfect straight line. It might have a slight curve in it because there is a reservoir, a small reservoir that it needs to go around near Los Adelmas, I think it's called. But that's the general route that it's going to take. Also, the actual tunnel itself will be clear of obstructions. There won't be anything in there other than a few sensors. There won't even be a walkway. It'll just be an open tunnel, which ensures the maximum flow. So at this moment in time, as you can see from our black lines, all the water from this reservoir is being shipped into Monterrey and the surrounding areas and used for residential purposes and industrial purposes. And what we want to do is tap into that existing supply network and just boost the supply of water into that reservoir and another reservoir up here up top, which is just over here. There is a reservoir here, which it's in a different state, but I've put in the option to add and subtract water from this reservoir just in case. It makes sense to have a connection to that reservoir because it is along the route anyway, so why not? So if we can help them boost their supply as well, and in the worst case scenario we can move water from this reservoir into this reservoir here. That's not very good. To this reservoir. Okay. So, just to make you aware that there will be a pump house here for pumping water in and out of this reservoir. I think it's called the P.R. Garcia Reservoir, but I forget. This will be a reservoir at a place called Los Trevino. There'll be a pump house. I'll have a maximum pumping capacity of 60 cubic meters per minute, which doesn't sound like very much, but it is quite a lot and is more than adequate to supply both the Tesla Gigafactory and all the new industrial opportunities that will be built in this area, plus potentially over 50,000 households as well. So it's more than adequate for what we're trying to achieve here. And if it needs boosting, we can always put in additional pumping capacity. We don't need to put in a new pipeline. We can add additional pumping capacity, potentially get it up to 100 and 120, maybe even 140 cubic meters per minute if that is necessary. But I think what we're proposing today is more than sufficient. So here's where our tunnel actually starts. As you can see, there's going to be a shaft here adjacent to the river, the Rio Grande. What we're going to do is build a weir on this part of the Rio Grande here. As you can see, there's like a bit of a dog leg where the Rio Grande splits into two. This is nice and wide, and the water's fairly deep, so it gives us an adequate supply. Plus, by building that weir in this location here, that's going to boost the depth up and above 1.6 meters, and then at that kind of level, we're going to pump water out into our shaft. We're going to have two pumps because we want one. Both pumps will be working at the same time, but obviously we want some kind of backup system in case one fails or one needs to have some maintenance activity. It'll be pumped into the shaft. Then the tunnel will be connected to the shaft, and that tunnel will run down to the reservoir, the main reservoir, at a gradient of about 1 in 800, maybe 1 in 1,000, something like that. It doesn't really matter too much, because this shaft here won't actually be too deep. It will be less than 10 meters deep, way less than 10 meters. Okay. So we'll call this the Giga pump house. It'll have a maximum pumping capacity of 80 cubic meters per minute. Ultimately, this pump house will not be active all year round. Between sort of mid-April and early August, it will be probably offline, if not very slightly online every so often, every couple of days. Maybe it's online 3 days a week, who knows. But so during the wet season, it'll be going 24 hours a day, and that's the idea, is that you want to boost your reservoir capacity when there is surplus water in that river. This is the final part. This tunnel, by the way, is just over 50 miles long. I'll show you the metrics later on. It'll be an open tunnel. There'll be a shaft up here as well, just up there, and then obviously there'll be a shaft here as well. As it progresses, obviously the shafts get deeper, so the shaft at the top might be 20-25 meters deep, whereas this shaft here could potentially be 40, maybe even 45 meters. But that doesn't truly matter too much, because we can just pump the water out at the volumes that are required. Ultimately, the aim would be to make sure that this reservoir is at 100% capacity for at least 3 to 4 months of the year. That would be the overall end game. Using this system and assuming that you can pump 100 cubic meters most of the 6 days a week, let's say 6 days a week, just to add in potential losses due to maintenance and various other things, you should be able to fill this reservoir in under 2 weeks easily. And you won't be running it at 100 cubic meters every day. It'll probably be 2/3 of that, closer to 70 or 66. Okay, so there's the details. How much is it going to cost? Is this going to be worth doing? And what are the benefits of doing this? So, number one, this is a problem region. There are some major problems with water supply, and it's only getting worse. So if you've got a large factory and there's massive overheads at running that factory, and you have to close that factory down for 3, 4, 5, 6 weeks because water shortages, you're in big trouble. So you want to be absolutely certain that water is never going to be a problem. So if you can spend this money, imagine the losses if you had to close that factory for 6 weeks. They would exceed this number. Absolutely guarantee it would exceed this number. And ultimately, you're giving your competitors free sales because you don't have enough supply. So it's in their interest to build this, and ultimately it will not only benefit the local people in this region but your local suppliers, and it will offer a solution potentially in the future for other regions of Mexico, and it will help the Boring Company, which obviously helps Elon because he owns most of the Boring Company. How much is this going to cost? So I've made a very pessimistic assumption that the cost per mile is 4.875 million. I actually think it's closer to 4, but hey, I broke down the tunnel into 5 sections. That means we need 5 TBMs. Also need 5 shafts as well, although some of these shafts will ultimately be used for the pumping houses, but I've included the price in here as well, actually. So it's in the price of the shafts, not to worry. Okay, so section A, because it's near to a river, will ultimately have difficult digging conditions, so you probably want to bring in a specialized machine, maybe a mixed face machine, or potentially even a slowy shield machine. But obviously I don't know the exact conditions, but we're just going to assume they're bad. So we've done a very short shaft here and assumed that it's clay, and the cost will be 6.58 million. If you add all this up, it's not too bad. We've got pump houses as well. Pump houses are not very much of the cost. Most of the cost is the actual shaft itself and the pumps, and then you have some connected pipework as well. And then I've put in 25.48 million for the actual reservoir itself, which I think is an overcosting, but hey. So overall 288.15 million to do this entire scheme, which I think is well worth it. Provides a lot of security for Tesla and provides work for the Boring Company as well. Okay, hope you enjoyed those costings. Hope you're interested in this project. Hopefully Steve Davis makes a proposal to Elon Musk and we get to see this built out, and it's definitely doable, and the costs are quite reasonable. If you look at that cost over a 10-year period, you know, it's only 28.81 or 82 million per year over 10 years, which is next to nothing when that particular gigafactory is going to be turning over billions and billions and billions of dollars every quarter, potentially every year, hundreds of billions, who knows, because it's going to be very high output, potentially up to 4 million vehicles. So hope you enjoyed that. Thanks for tuning in. Please like and subscribe if you've not already done so, and comment on the video. Tell me which bits you liked the best. Follow me on these platforms. If you've not already done so, consider supporting me on Patreon. And as always, thank you to all my incredible Patreon supporters. And yeah, hopefully we'll see you on the next video. Take care now, and remember, don't be boring. Have a good evening. Goodbye.
And with artificial intelligence, we are summoning the demon.
Hail to the king, baby.